Hello, welcome to our third micro lesson. This one is on why you shouldn't read your slides. To start, I want to come back to this model of memory that I've used for the last two micro lessons. Last lesson, I focused on what too much information means and how it is different for novices and experts because of the expert's ability to chunk information into bigger pieces. For this lesson, however, I want us to focus more on the characteristics of working memory. And to examine working memory, we're going to do another test. For the first test, I want you to count the number of words in a sentence. It's the sentence that has every letter of the alphabet in it. The quick brown fox jumps over the lazy dog. Now, pause your video and count the number of words in that sentence. Okay, are we ready? Here we go. There are 9 words. Now, that was only part of the test. For the second part of the test, I want you to count the number of corners in a block letter E. Again, pause your video and count those corners, both the inner and outer corners. Are we ready? Okay. In this case, the answer is 12. So why did we do this? What did we learn? I suspect that when you counted the block letter E, you didn't use your fingers to count. You might have pointed at the block letter E you were imagining in your head, but you kept track of the count in your head. I suspect that when you counted the block letter E, you didn't use your fingers to count. You might have pointed at a block letter E you were imagining, but you kept track of the count in your head. However, when counting the sentence, most people use their fingers to keep track of the count. The reason for this is something called dual channel theory. It turns out that working memory has 2 distinct components, each of which work independently and can be independently overloaded. There's the verbal or phonological loop, which is used for things like words or numbers. So when thinking of the sentence, these words took up all your verbal working memory. There was no room for counting. Luckily, humans evolved with an external memory device, so you could count on your fingers. In addition, there is the visual or visual-spatial sketchpad, which is used for images. So when you counted the corners, you could imagine the letter in your visual memory and count in your verbal memory. These ideas were first presented by Baddeley and Hitch in 1972, and they continue to be refined. Other researchers have experimented on how we use these 2 processes to interact with the world. For example, Johansdotter and Herdman used this to investigate situational awareness in drivers. Using a driving simulator, they found that drivers estimate the position of cars in front of themselves using the visual-spatial sketchpad, which makes sense. We can see those cars. However, drivers estimate the position of cars behind them using the phonological loop. These experiments work by intentionally overloading one aspect of the working memory, for example, conduct a secondary task on rhyming words, and assessing how that affects the primary task. But how does this apply to slides? Well, let's show an example. One thing we have a lot of in STEM is definitions. And this is how we often teach it. Pretend you're in a class and the instructor brings up the definition and starts reading. Systems engineering is an interdisciplinary approach that encompasses the entire technical effort, and I'll stop reading there. The problem is that text and speaking voice both use the phonological loop. Text is not an image. It is not processed by the visual spatial sketchpad. Reading and listening at the same time overloads the verbal channel and information can be lost. Specifically here, because people read faster than people talk, the 2 messages are out of sync. So, students have 3 choices. Read what's on the slide and ignore you. Listen to what you're saying and ignore the text. Or, and this last one is often the choice I make, ignore both, wait for you to finish reading, then read it myself, which is usually when you're about to say something important. How do you fix this? Well, if you have a YouTube video, you can synchronize the 2 messages. Here we're going to have a definition of systems engineering, which can be defined as an interdisciplinary approach that encompasses the entire technical effort and evolves into and verifies an integrated and life-cycle balanced set of systems, people, product, and process solutions that satisfy customer needs. Unfortunately, that's probably impossible in a classroom setting. But there's another option. Use animation to highlight key aspects. For example, there are many definitions of systems engineering, but they all have 3 things in common. They all take an interdisciplinary approach, they all focus on life cycle, and they all have a focus on the customer requirements or needs. Notice how in this case, I didn't read the definition and I used visual cues to highlight verbal cues. We'll talk more about visual cues in the next micro lesson. But for this lesson, the key takeaway is don't read your slides. The text on the slide and your spoken words both use the same part of working memory. Sure, you can read short things, but if you read a long paragraph, you will overload your student's phonological loop and they will not be learning. As an aside, sometimes the exact text is critical and long, but you still shouldn't read and show it at the same time. You have 3 options. Option 1, read it, then display it. Have the text written somewhere so you can read it out loud to the audience and then bring up the written word on the screen. Option 2, put it on the screen and let the students read it without you saying anything. I usually read it silently to myself 2 to 3 times, then start talking about it. Or option 3, make a handout. Just because we have slides doesn't mean everything should be on a slide. Thanks for listening, and good luck on your teaching and learning journey. As always, your feedback and ideas are appreciated. Please click the like button, subscribe, and tell your friends to come join us.